for those who from group L, basically my class is still in chapter 4, and I was told by Madam Nur Asma yesterday that your class has moved to chapter 5 yesterday. Okay, but it is okay because we are planning to finish all chapter 4 by today, and then next class perhaps after New Year break we are going to have chapter 5 and 6. Okay, then just want to mention to you. Okay, so we actually have 8 topics altogether. Now we are in chapter 5, chapter 4. Okay, so after we have finished chapter 4 under air pollution, we are going to have chapter 5 and 6, which cover the solid waste management. Okay, and then chapter 7 is the scheduled waste, not very much. The slide is not too much, okay, just a little bit. And then for chapter 8, we are going to replace the topic with the talk from the industrial people. Okay, we will invite them, and then they have already agreed to give the talk to all of you, okay, regarding on how to make the EIA report especially. Okay, so the lecture series, okay, on the EIA report, which is chapter 8, will be done expected in week 13. But we are still not deciding, still deciding what is the day, date and also time. Okay, so that one will be informed from time to time. Okay, boleh eh? Okay, class, is it okay? Okay. Okay, now, before we start with the last part of topic 4, I just want to finish up example 9.3, the one which is in the textbook. Okay, so in the previous class, we have looked example 9.1 and also 9.2. So 9.1 was the cyclone example, and then for 9.3, it is actually the bag filter example. Okay, so let's look the example and also solution. Okay, it's stated here for example 9.3. Okay, a fabric filter is to be constructed using the bags, okay, which is 0.3 meter in diameter and also 6 meter long or length. Sometimes they use the length and they replace with the term high. So it is 6 meter long or 6 meter high. Okay, so afterwards we are going to see how does this bag house is constructed. Okay, and then the bag house is to receive 10 meter cube of air, 10 meter cube per second of air. This is the flow rate of the polluted air, and the appropriate filtering velocity has been determined to be 2 meter per minute. Okay, we are going to see in the diagram which part that we can call as a filtering velocity. Okay, and your task is to calculate what is the number of bags required for a continuously clean operation. Okay, before we jump into the solution, basically what you have seen down here is the solution, but I want to draw it so that you can more understand on where is the location of diameter, the length, and then the flow rate of 10 meter cube per second, and where is the location of the filtering velocity inside of the bag house. Okay, let's look into the slide notes. Okay, just want to share with you that which part that I have referred to before I draw the filter bag. Okay, so this is under bag filter. Okay, so can you see these slides, class? Can you see this slide? Okay, so now we are going to look. Okay, what we have here is the bag house filter. Okay, you have the dirty air that is come from the left hand side, and then dirty air, or another name is polluted air. So we have the polluted air goes into the backhouse filter, and then you can see that we have brown color here to show this is the bags. Okay, you have to understand that each of this brown color here is called the bag. Okay, for example, you have 1, 2, 3, 4, 5, 6, 7, 8. This we have 8 bags, and the total of bags is referring to the bag load. Okay, so this is a bag load. So maksudnya kalau bag load tu adalah compilation of the bags, okay, inside of the bag filter house. Okay, ataupun kita panggil nama lain adalah total cloud area. Total cloud area ni adalah semua ni, tapi setiap daripada brown ni dipanggil filter bag, okay, ataupun bag filter. Okay, so now, okay, once the polluted air comes in, okay, into the backhouse filter, so the polluted air, since it is lighter, so it will travel upwards. Is it right? Das, is it right? Boleh siapa-siapa respon Kecil saya tak tahu you tak dengar ke atau lagging ke?
Yeah. Dengar.
Okay, good. Okay, and then the polluted air, okay, since it is lighter, it will travel upwards. Okay, class, can you see the blue color one? Ni yang arrow biru ni, boleh nampak tak?
Nampak, madam.
Okay, actually the blue color one is referring to the filtering velocity. Filtering velocity means the velocity that is needed to filter out or to separate the particle from the gas ataupun air. Okay, so that is why the blue color arrow to show that the velocity of the filter is located here. So of course the velocity in the filtering bag and also the flow rate from the polluted air will be different. So kita expect filtering velocity through the bag filter ni dia lagi kecil lah compared to the polluted air that comes into the ataupun goes into the backhouse filter. Okay, so to okay, so this is the solution. Okay, can you see the slide? Sorry, the PDF?
Yes, madam.
Okay, so this is what I have copied actually from the slides, okay, that you have seen just now. So basically, you have the polluted air comes from the bottom side, the left-hand side, and goes through the filter bag. Okay, so of course here you are given with diameter. So diameter is actually referring to here, diameter. Okay, and then the length, or sometimes they call as height. This is the length. Okay, length or height. Okay, and then the polluted air which goes into the filter bag, we have the Q here. Basically Q dekat sini dekat polluted air ni, the 10 meter cube per second. And then once it goes to the bag, and then it start to filter through the filter bag. Okay, ni macam contoh ni you nampak ada 4 filter bag dekat sini So these 4 filter bags, bila dia compile dia akan jadi cloud area. Itu you kena faham beza cloud area dan juga filter bag. Okay, ataupun in other words, we can say that summation of the filter bag makes one cloud area. Okay, ataupun total cloud area. Okay, so now I simply label the arrow here yang you nampak in the previous slide tadi color biru kan. So that one referring to the VF, it's known as the filtering velocity. Here is stated that it is given as 2 meter per minute. Okay, so I simply state here this is through the filter bag or bag filter. Okay, finally after the polluted air is filtered, so the clean air will dispose at the top while we have the particle which is trapped through the bag filter. Okay, and then since we have seen animation before this, we need the pulse repulsion, the jet repulsion force from the top, okay, in order to push out all the particles so that it will fall into the particle collector, okay, ataupun hopper. Okay, so now the question is you need to calculate what is the number of bags inside of this total cloth area. Okay, ingat ya, the summation of total of bag makes one cloth area. Okay, okay, so the first step is to calculate the total cloth area. So you are given with the flow rate now 10 cube per second. You simply convert velocity. Just now it is given in minute. So when you convert it to minute, you can simply calculate the total cloth area. Saya rasa ni equation mathematics kan yang you belajar dulu. Is that right? Q equivalent to VA. Is that right?
Yes, madam.
Okay. So you can simply calculate the area so that finally you can get the total cloth area. Okay, total cloth area ni adalah the area for the one whole bag, 300 meter squared. Okay, so now you know already the total cloth area for the one whole system here is 300 meters squared. So the question is, how many of filter bag that is contained in that total cloth area? Okay, so after you have obtained the area, you need to calculate the area of one bag. Okay, so knowing the fundamental, okay, because this is the front view, right? And then if you see from the 3D view, it is actually the shape of cylinder. So that is why in order to calculate the area of one bag, it is area of cylinder. This is the area of cylinder, okay? Pi dl or pi equation, this is a mathematical equation to calculate for the cylinder, okay? Total area cylinder. So you have pi dl, okay? So you have a 5.65 meters squared, okay? So now you have two types of area. One is the total cloth area, and another one is area of one bag. Therefore, finally, you can calculate what is the total number of bag by simply dividing the total cloth area with area of one bag. Okay, so since the answer is 53.05, so bila you round off tu, you tak boleh round off 53 kan, sebab dia dah terlebih 0.05. So you have to round off ke depan. Okay, so you cannot round off as 53 because it has exceeded 0.5 dekat sini. Therefore, you round off to forward, okay, as a 54 bags. Okay. Okay, class, are you clear with this?
Boleh, madam. Dengar.
Okay. Okay, so hopefully you can already do the tutorial question 9.10 and 12 is both are for cyclone. 9.19 is for the bag filter. Okay. So that one kita akan discuss after the new year. So that one is for tutorial. Okay. So the next part will be the slide notes. Okay, kita continue lecture. Okay, let's just recap what we have learned before this. Okay, before we move to the next subtopic under chapter 4. I just don't want you to get confused. Okay, let's look on these slides. Okay, we have looked before this the devices or the equipment that is needed to control or to reduce the particle content in the air pollution. Okay, so apa yang you nampak ni sekarang, gravitational, okay, and then you have centrifugal, you have cyclone, and then wet collectors such as scrubber, spray tower, fabric filter dan juga ESP, which is electrostatic precipitator. These are the equipment that is used to remove the particle content. But some of the particle, okay, can be classified as dry or wet. Okay, selalunya contohnya gravitational chamber and also centrifugal collector are usually used for to separate the dry solid or particle. Whereas for wet collector, dia boleh separate the dry solid as well as the wet phase. Okay, such as yang kita tengok dalam spray tower hari tu. Okay. Okay, this one is meant for particle removal. Okay. Now, what if you want to remove the polluted gas? Okay, so for polluted gas, kita ada different equipment, but some of the equipment have the similar principle as one of these equipment. Okay, so jangan confuse ini untuk remove particle. Okay, so for gas, okay, so this is actually the equipment to remove the gas contaminant. So if you notice, I simply highlight the word, I simply highlight the word gases contaminant. Okay, so that you tak confused. Okay, so this is the gases contaminant. Okay, the major treatment processes. Okay, we have absorption. Okay, remember the difference between AD and AB. I have explained this in the previous class. Condensation and combustion. But on top of this, we focus more or give the priority, okay, to the removal or to control the SOx, NOx, and also CO, organic, okay, and then acid gases, and also HC removal, hydrocarbon removal, because this is much more crucial, okay, compared to the absorption, condensation, and also combustion. Okay, but as for today, okay, since this is quite long slides, okay, so I plan to finish all under the SOX ataupun VOC component ni, removal, and then we go to absorption, AD, okay, and then condensation and also combustion. While for absorption, I'm going to give you the pre-recorded video, okay, because we are running out of time now. Okay, in fact, once you come back from the holiday, again, the Monday is public holiday. So we are going to meet on Thursday, okay, on Thursday in the week 11 later on, because now it's already week 10, okay. Okay, so we start with the first one, okay, the VOC, NOx, and SOx. Okay, we normally talk about the VOC before this. Okay, what is VOC? Okay, what we have in mind is that VOC is very toxic, very carcinogenic. So what is VOC actually? Okay, it is stand for volatile organic compounds. Okay, so the condition is that it is either exists as a liquid or solid, okay, that contains organic carbon. Okay, so the keyword is the carbon content in the compound. Okay, usually this VOC will vaporize, okay, at the significant rates, and since it is vaporized, so it means that it converted from the state, and this vapor is very toxic and carcinogenic because it can harm the lung, okay, of the human being. Okay, but knowing that our industry, for example, the releasing of VOC, NOx, SOx, NOx is some, maybe it can have NO2, NO3, and so on, SO2, SO3, okay. So these are the common gases that is released from the heavy industry, for example. So it is quite hard for us to eliminate 100%, okay, of this emission, but what we can do is that we try to minimize the releases of this VOC compound, okay. So these are what we can do in order to minimize it. So first, maybe we prevent, okay, by the substitution, okay, prevent at the source, okay, maybe by substitution of the raw material that you use, okay, into much more safer component, okay, so that you can minimize the VOC. Okay, next, maybe you can modify the process itself, okay, or you control the leakage from the equipment. Okay, you can also do by altering the concentration and also the recovery of the product, such as by using the condensation, adsorption and also absorption. Under absorption ni kita dah tengok sebenarnya dalam scrubbing section in the air control equipment in previous class. Okay, and then next we have also oxidation process, such as through the combustion and also biological oxidation. And this is just to show you the example of the releases of the SOx and NOx, which is mainly come from the industries, okay, such as a power plant, refinery, transportation, and etc. And since it is volatile, it can affect the respiratory in the human being, as I mentioned just now. And these gases also can form secondary particle in the atmosphere. This is a very dangerous, because we have heard before this during haze in Malaysia last time, when we have the formation of PM10 and PM2.5. PM means particulate matter. 10 and 2.5 is actually to represent the size of the particle that goes into the lung. Okay, so the smaller is more dangerous. Okay, and as we know, the SOx and also NOx releases can cause the acid rain. Okay, so to be more specified, okay, because just now we have looked into how you minimize the VOC, but if you want to minimize the SOx and also NOx releases, okay, you have maybe respective treatment, such as if SOx, usually the common treatment is to minimize by using the absorption process. Maybe maknanya kat sini kita guna absorber, this is stripper, okay, and also wet scrubber. Okay, so these are the common equipment. Whereas for NOx, usually we use the method by using catalytic reduction. Okay, this is the true direction itself. Okay. Okay, we go for the first one. This is adsorption. Okay. So what is adsorption? Adsorption is the addition of molecule or the stickiness of that particle. Okay, remember the target is to remove the gas, okay, from the particle. Okay, now adsorption is defined as the addition of molecule. So the molecule or the particles here doesn't matter. It appears as a gas, liquid or dissolved solid onto the surface. Because we have looked into the definition before this, if for adsorption, what is the difference between adsorption and also desorption? Absorption, AB and AD. Okay, we have looked before this, the major difference of AB and also AD. Okay, let me just share the previous lecture. Okay. Okay, this is a diagram that we have discussed in the previous class. Okay, we have looked into the schematic diagram, the difference between AD and also AB. Okay, so basically the AD, okay, it means that the particle content, okay, or the particle would only can be stick onto the adsorption layer only, okay, or adsorption surface. Okay, or in other words, we have adsorption, the addition means the stickiness, okay, or the impingement of this particle onto the surface only. Okay, but for absorption, okay, for AB, the particles, it can actually diffuse through the substance, okay, not only on the surface but also through the substance and into the substance itself. Okay, so basically for absorption ni kita ada we have the pores, okay, and then since the particle is much smaller, so it can diffuse through the absorption. Whereas for the AD absorption, the particles only lie stabilize and also line up on the surface. Okay, we're going to look into detail what is the adsorption and absorption later. But now we focus on AD dulu. Okay, adsorption. Okay, let's move into the next slide. Okay, so now if the adsorption is defined, okay, as the addition or the stickiness of the particle onto the surface, okay, so you need to know what is the difference between adsorption and also adsorbent. What is adsorbent class? Adsorbent means the surface, okay. You have adsorption, adsorbent, and also adsorbate. Okay, if I have three terms, okay, for example, I have the adsorbent, adsorbate, and also adsorption. So adsorption is a process. Okay, adsorption means the particles is stick, okay, onto the surface. Okay, so the face here, the face here is called as a, the surface is called as a adsorbent. Okay, but for the particles, it is known as a, okay, saya tulis kat sini. Okay, sometimes the molecules now, since we are focusing on the gas pollutant, so the molecules is known as the particle, or we call as a adsorbate. Okay, maybe adsorbate. Okay, and then adsorbent is actually to the referring to the surface that this molecule or particle tadi stick onto. Okay, so I hope that you are now clear with the term adsorption, adsorbate, and also adsorbent. Are you clear with this?
So far, okay, madam.
Boleh faham Okay. So this is very important for you to understand the different term that is commonly used in the adsorption process. Okay, adsorption is a process. Adsorbate referring to the particle. Adsorbent is the surface. Okay. So the mechanism is very simple. Okay, it involves the passing a stream of effluent gas. Effluent gas means the polluted air through a porous solid material. Okay, so this one porous solid material is referring to the adsorbent, the surface. And for the adsorption process, it can be classified as the physical or chemical process. Okay, so we go for the first one, physical. Okay, this is a physical. But before we read all of this, let me just share with you the schematic diagram so that you will understand better. Okay, this is what I have. Okay. Okay, class, can you see this diagram? The PFT diagram?
Yes, madam.
Okay. Okay, so to understand the physical and chemical, okay, this is what the obvious difference, okay, or the significant difference. So if I have physical adsorption, nama lain dia adalah physisorption. Okay, if I have the chemical adsorption, nama lain adalah chemisorption. So basically we have discussed just now, imagine that we have yang bulat ni adalah particle, okay, known as adsorbate, and we have the surface here known as adsorbent. Okay, so both you can see that we have a same figure, right? But how these particles, okay, is holding on the surface. Okay, if physical or physisorption, usually kalau kita enlarge gambar ni, okay, let's say I just enlarge it and I just take one example of the particle. So between this particle and the surface, there is a force known as van der Waals. Okay, so what is the characteristic of van der Waals? Class, is it strong or weak force? Anyone can answer?
Weak force.
Yes, weak force. Okay, good. So since the force is very weak, it means that this particle can detach, okay, can detach or dissolve at any time. Okay, detach mean maknanya particle tu boleh saja mula-mula dia stick on the surface dan this particle can detach, okay, detach from the surface. Maknanya dia boleh lie sekejap dan juga dia boleh keluar balik. Okay, because the force is very weak, it means that the force that is holding is very very weak, so it can easily detach from the surface. Okay, faham maksud detach ya? Class, can you understand what is the meaning of detach?
Faham madam.
Okay. 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 So detach, so it means that if the force is weak, so this particle can easily detach from the surface and go elsewhere. Maknanya dia tak melekat lah. Okay, not stick to the force. Not stick to the surface. Okay, whereas for the chemical or chemisorption, okay, if we enlarge this diagram, okay, what can you see is that, okay, you have the particle here and then you have the surface. So the particle is adsorbate and then the surface is adsorbent. So the force that is holding this particle onto the surface is known as the valence force. And this valence force is very, very strong so that this particle will not detach. So maknanya dia stay lah dekat atas surface tadi because it is very, very strong that is holding these particles, okay, on the surface. Okay, so in conclusion, we can say that the chemisorption has greater force, okay, compared to the physisorption. Do you agree, class? Class, do you agree?
Yes, madam.
Okay, chemisorption has stronger force compared to physisorption. Okay, logically, if the chemisorption has stronger force compared to physisorption, which type of adsorption here required more energy in order to release this particle? Is it chemisorption or physisorption?
Chemisorption.
Yes, chemisorption, because we need very high energy to overcome that force so that then only you can release this particle as well, not stick on the surface. Okay, okay, good. So maksudnya you faham lah principle physical and also chemical adsorption. Okay, so when you go back to the slides, okay, so now it is much more easier for you to understand lah sebab kita dah tengok principle tadi. Okay, so the physical adsorption, what we can is here is that, okay. Okay, so the physical adsorption, it involves the condensation of the gases and also vapors on solid above the dew point. Okay, so the particle, it can be gases or the vapors. Okay, and it depends on the van der Waals forces, which is very weak. Okay, for the physical adsorption, and it's stated here, the higher the boiling point, okay, of the polluted gas, the greater the amount of adsorb. Okay, or in other words, when you have higher boiling point, the adsorption process is high. Okay, maknanya lagi banyaklah particle dia akan attract onto the surface. Okay, so since we have this relation, we can say that it is directly proportional to the amount of solid surface available. It means that the bigger the surface you have, the more amount of the particle that you can attach to the solid. Okay, again I repeat, the bigger solid surface ataupun the bigger of adsorbent that you have, the surface area, there will be more amount of particle that will be attached on the surface. Okay, and it is accompanied by the capillary condensation. We did the pause. Okay, kita akan tengok nanti. And since the force is very weak, you just need very minimal heat or energy in order to release the particles, okay, back to the atmosphere. Okay, and then also since it is very weak, dia proses dia sangat cepat. Maknanya dia the particles is very fast okay, or very rapid process. So the particle will stick on the surface, okay, due to the van der Waals force. And then since the force is very weak, dia juga boleh detach from the surface. So proses tu berlaku sangat cepat, rapid. And then it is readily reversible. Why reversible? Because at one point or at one time, the particle will attach to the surface. Okay, but remember, it is holding by the very weak force, which is van der Waals force. Okay, and since it is very weak, at any time, the particle can be detached from the surface. So that is why we call it as a reversible. Maknanya sekejap dia melekat, sekejap dia detach semula ke atmosphere. So sebab tu dia reversible. Okay. And then by lowering the pressure and also increasing the temperature, adsorbed gas can be dissolved. Or in other words, we can say that the adsorption process can be increased if you lower the, this is adsorbed gas can be dissolved. Okay, maknanya in other words, if we translate to different sentence, okay, if you want to increase the adsorption, you kena terbalikkan lah dia punya condition ni. So ini adalah dissolve. Dissolve means dia detach daripada surface. So I can say that if you want to increase the adsorption, you have to increase the pressure and also decrease the temperature. Ini terbalik Adsorption dengan desorption tu terbalik. Adsorb means the particle stick into the onto the surface. Kalau desorption, the particle go away from the surface ataupun release back to the environment. Okay, chemical adsorption, as we have seen just now, it is holding by the valence force, which is very strong force, and it forms a chemical bond with the adsorbent surface. And it is a slower process since displacement of the atom must occur in molecules. Okay, why it is slower process? Because since it is holding by very strong force, so in order to increase the force, the process is very slow for the chemisorption. But even though the process is slow, eventually, since the force is very strong, biasanya chemisorption ni adalah irreversible. Dia maksudnya once dia stick on the surface, sangat-sangat susah untuk dia dissolve semula because of the strong force. Okay, class, do you agree with that? Class, do you agree with that? Since the force is very strong, so dia adalah irreversible. Maknanya very hard for the particle to release back to the atmosphere. Is it true? Do you agree? Okay, good.
Yes.
Okay, good. Okay, and also we have discussed just now, since the force is very strong, you require a very large amount of energy and heat in order to, let's say you want to do the desorption, the possibility that you can do the desorption is very, very low. Okay, because of the strong force. Okay, sebab dia sepatutnya irreversible. Tapi kalau you cuba juga untuk break down the force, you really need a very high amount of heat and also energy. Okay, and then the amount of the gas, okay, adsorbed depends on the pressure and temperature. This one we have looked in the previous slide. Okay, so how to increase the adsorption by increasing the pressure and also decreasing the temperature. Terbaliklah daripada term ni. Okay, and I am interested with the line here, results in the formation of single layer. Okay, just now we have looked into the adsorption classification. One is physical adsorption, and another one is chemical. But under the chemical adsorption itself, kita ada single layer dan juga multi-layer. So what is single layer and also multi-layer? Okay, ini pun saya ada schematic diagram. Okay, can you see the diagram?
Yes, madam.
Okay, we go for the single layer first. If single layer, it means that all the particles line together in single layer only. Okay, so it means that we are now talking about the chemical adsorption. So chemical adsorption, we have a very strong force. Is it right? Is it right, class?
Yes.
Okay, So what if now we have the multi-layer adsorption? So multi-layer means you have more than one layer on top of each other. So untuk example ni kita ada 3 layer, 3 layers Okay, if we talk about the force effect on this multi-layer adsorption, so I can say that the first layer of the particle, we have much stronger force towards the surface sebab dia yang paling dekat dengan surface. But whenever you have higher and higher layer, okay, because it is far away from the surface, so the force that is holding each other will become very weak. So it means that for multi-layer adsorption, biasanya the highest layer would have the tendency to become detached from the surface sebab dia jauh daripada surface. Okay, class, do you agree with that?
Setuju.
Sebab dia jauh daripada surface, so dia ada tendency untuk detach easily, so dia tak memerlukan very high energy to detach. Okay, dia nampak macam principle lebih kurang macam jadi macam apa physical, tapi physical tu sangat low lah because van der Waals. But for multi-layer we still have the valence force, but the valence force for the upper layer akan lebih weak daripada the one which have the single layer for the first layer. Okay, so this is the, just want to share with you the difference between single layer and also multi-layer. Okay class, any questions so far?
Tak ada.
Okay okay. Okay, so back to the slides. Okay, so this is all about the physisorption, chemisorption, and also under chemisorption we have looked into the difference between the single layer and also multi-layer. Okay, so the next one, okay, this is just to share with you the simplest example of the adsorption equipment. Okay, let's say the left hand side here we have the carbon bed. Carbon bed ni function dia adalah adsorbent. So now what we have is that at the top column we have the polluted air that goes into the adsorption column. Ini dipanggil adsorption column Okay, and then once the polluted air goes into the adsorption column, okay, so the carbon bed here, the function of this carbon bed is to trap all the particles from the air. Okay, and what happened to the clean air? So the clean air will go to will push to the next adsorption tower or adsorption column, and finally we have the more cleaner air. So kenapa ada dua? Because ini adalah contoh regenerative carbon adsorption system. So it means that we have the treatment is much more efficient compared to non-generative carbon. Okay, non-generative selalunya kita ada satu saja unit. Kalau regenerative, it can be more than one. It can be 2, it can be 3. So depending on the company setup. Okay, and also the requirement of the industry itself. Okay, for this example, we have extra bed because we want to regenerate. Okay, regenerate ni lagi untung lah sebenarnya sebab kita boleh in terms of quality of the clean air that you produce is much more better compared to the non-generative. Non-generative ni dia one off saja, sekali saja. Okay. Okay, and then what is the function of steam generator here? Okay, the steam generator is used to push out the captured pollutant. Okay, just now we have mentioned that the function of this carbon bed is to trap out all the particles. Okay, so macam mana you nak keluarkan? How you want to push out these particles to the collector ataupun dust collector? So you need the steam generator to push out. Okay, so that finally it will be collected in one tank, okay, called as a dust collector ataupun particle collector ataupun dipanggil hopper. Okay. Okay, just now we have looked into adsorption, okay, adsorbent and adsorbate. Okay, so bila saya bagi tahu tu you boleh imagine ya. Okay, so now we want to see the adsorbent itself. Okay, what is the good characteristic of this adsorbent? Okay, first you have to look into the affinity. Affinity means you have to check whether substance is polar or non-polar. Okay, for example, polar maybe you have alumina or bauxite, silica gel, and also maybe non-polar examples such as lower paraffin, hydrocarbon, and so on. And the expensive adsorbent also, such as xylite, it is very efficient and effective, but the drawback is it is very expensive. Okay. Okay, and then the next one is the second factor is to surface to volume ratio. Okay, surface to adalah we are referring to the surface area of the adsorbent to the volume, okay, of the polluted gas. Okay, provided by the internal pores. Okay, macam mana maksud dia tu? Okay, ini pun saya ada schematic diagram. So sebanyak yang saya buat drawing schematic diagram so that you boleh lebih faham. Okay, so can you see this diagram?
Boleh tu.
Okay, so imagine that what you have seen here is a circle or the sphere. Okay, imagine that this is an adsorbent, one unit of adsorbent. Okay, the adsorbent, some adsorbent is non-porous. Non-porous means you do not have any pores. Okay, maknanya porosity dia zero, tak ada pores langsung. Okay, and then contoh porous tu macam guli guli kan, dia main kecil dulu. Okay, and then for porous, porous instead of having non-porous, okay, kita ada pores, okay, inside of this adsorbent. So maksudnya if let's say if we have the particles from the gas, okay, what you have is that if particles if you use the non-porous adsorbent, okay, at the right hand side here, okay, so the right hand side here, if non-porous, it means that all the particles will only lies on the external surface only. Ni adalah surface area, we are talking about the surface area now. Okay, if non-porous, all the particles will only stick on the external area of the adsorbent only. Whereas for porous, since we have pores, okay, ini yang dalamnya adalah laluan pores. Okay, so the particles is not only stick on the external surface, but also will stick into or inside of the adsorbent. So itu dalam ni semua kalau you nampak ada dotted warna hitam ni, so it means that the particles has been absorbed through the porous, okay, porous area. So ini dipanggil internal area. Okay, so now if you want to compare in terms of porous surface area, for porous adsorbent, we have the factor of internal surface area which is from the pores, dan juga you ada factor external surface area. Whereas for non-porous, we only have the external area as a factor. So in terms of porous and non-porous, which one that you expect to have more surface area? Class, anyone?
Porous.
Okay, porous. So usually we prefer the porous adsorbent compared to non-porous, because lagi banyak surface area, the absorption will be better. That is the principle. The higher the surface area of the adsorbent, so the absorption process will be better. Okay, again I repeat, the higher the surface area of adsorbent, so the absorption process will be better. So in this case, we prefer the porous to the non-porous. Okay, maknanya non-porous ni sikit sajalah sebab kita ada external area only that can be considered. Okay class, any question on this? Class, any question?
Ada, Madam.
Ada okay, boleh clear Okay.
Boleh.
Okay, so since you have we have discussed the schematic diagram, so I hope that this explanation will help you to understand better. Okay, so now when we talk about surface to volume ratio, it is actually referring to the surface area, total surface area of the adsorbent to the volume of the gas, okay, volume of the polluted gas yang masuk, okay, and it is provided by the internal pores. Ini referring kepada porous, okay, porous adsorbent. Okay, and how do you increase this the surface to volume factor? Okay, for example, let's say you have a activated carbon. Okay, so how you increase the activated by activating some adsorbent? It means that you have the activated carbon. So how you increase the surface to volume ratio factor? Okay, example, what you can do is that maybe you can treat with the steam. And if you have activated alumina, maybe you reactivated it by heating the temperature from 175 to 3 to 5 degrees C. Okay, so this is what you have, xylite, silica jet. Ini yang common lah, xylite. Okay, boleh kita break sekejap dalam 10 minutes? Kelas, is it okay?
Boleh, madam.
Okay. Okay, kita akan sambung dalam 9:40 sebab tak banyak dah, sikit lagi.
Okay, madam.
Okay. Okay, class, can we continue? Just a few more slides.
Okay, madam.
Okay, madam.
Okay, so I will start now. Okay, so just now we have looked into the fundamental of adsorption. What is adsorption? What is adsorbent, and then what is chemisorption, physisorption, what is single layer and multi-layer. Okay, so now we want to look what is the equipment, okay, equipment principle that is used in the adsorption procedure. Okay, basically under adsorption, it can be designed either with fixed column. Okay, fixed column means not moving, or the next one is moving column, but the adsorbent is still there, or it is not moving. And one more is the fluidized pad. Okay, if we want to see the example of fixed pad, okay, we go one by one. Okay, the one that we have looked into the this example, okay, yang you nampak sekarang ni, yang carbon bed example ni adalah contoh fixed pad. Fixed pad means you install the adsorbent, okay, as a carbon bed. Maksudnya sekarang the position of the adsorbent into the adsorption column. Okay, but so the function of this carbon bed as a adsorbent, it absorbs all the particles, okay, and leave finally the treated gas, okay, or the cleaner gas. Okay, ini adalah contoh fixed pad. Fixed pad means the position or the adsorbent is not moving, it is stick there, okay, with a certain level. Macam contohnya carbon bed ni, you put it in the carbon bed maybe at the length of maybe 3 meters, for example. So the position is static here. Okay, so it means that the adsorbent is static in the carbon bed position as in 3 meters height. Okay, at the fixed condition. Okay, itu maksud fix, maksudnya kita fix kedudukan adsorbent tu dalam kolom. Okay, so that is why for fixed bed, since it is fixed, so sama ada you nak susun dia secara vertical as this example. Okay, in carbon bed here, this is an example of a vertical. Okay, we can also have a horizontal slide, okay, horizontal position. Okay, but as long as it is a fixed bed, okay, it can be either vertical or horizontal. Okay, in a cylindrical shell. Okay, example, maybe you can use the activated carbon as the adsorbent. Ini contoh application. Okay, what is moving bed adsorber? Okay, so the principle is the adsorbent is contained in the rotating drum. Okay, if you want to understand this, because maybe some of you confuse what is the difference between moving and also fluidized bed. Okay, untuk moving bed adsorber, the one that is moving is the drum, but the adsorber is static at that condition. Okay, so I will share one of the schematic diagram. Just want to let you more understand with this. Okay, so what you are seeing now, this is a moving bed adsorber. So what happened is that, okay, so imagine that you have the polluted air coming from the left hand side, okay, and then this polluted air with the help of exhaust fan, so it will drag more polluted air that goes into the rotary drum. Okay, ini contoh yang tadi tu kita panggil rotating drum. Okay, so this rotating drum, okay, what happened is that, okay, the big thing here, the circle drawing here is called as rotating drum or moving bed adsorber. Kenapa dia panggil moving bed? Because this drum is rotating. Okay, this drum is rotating. Maybe for this example, it is rotating in clockwise, okay, direction. And then where is the position of this adsorber? So ini just tunjuk you kita ada 4 compartment in this rotating drum. Okay, I just show you one compartment example only. Okay, imagine that each of this compartment containing all the adsorber which is packed, okay, with the adsorbent. So maksudnya column adsorber ni kita pack, okay, kita packkan dia, okay, dalam setiap section ni. Okay, just show you just show to you one example of the portion. Okay, so imagine that is packed into each of this section. Okay, so it is the adsorbent is placed in contact to each other. Okay, sangat rapat, close to each other. So what happens is that when polluted air is exhausted by the fan, this fan, through this moving back adsorber, so what is moving now is the rotating drum, but the adsorber ni dia static dekat situ. Okay, mana dia tak bergerak. Okay, dia hanya bergerak mengikut pusingan rotating drum sahaja, tapi dia sendiri tu dia tak bergerak, dia adalah static at that condition. Okay, so what happen is that once the polluted air goes into the moving back adsorber, okay, so it will trap all the particles from the polluted air, and finally we will have the cleaner air at the right hand side here. But this rotating drum, it will keep rotating during the process. Okay, so maksudnya faham yang bergerak tu dia adalah rotating drum, tapi dia punya position tu masih tetap kat situ walaupun dia ikut bersama tapi dia tak berubah. Okay, unlike the fluidized pad, fluidized pad ni dia lain sikit. Fluidized pad ni maksudnya all the adsorbent is moving and floating. Yang ni saya ada animation untuk tunjuk. Okay, so continue about moving back sebelum kita masuk the fluidized pad. Okay, so adsorbent is contained in the rotating drum. So the contaminated air is moved by the fan into the rotating drum. Ini faham maksud ayat ni kelas? Boleh faham So you dah tengok gambar tadi kan?
Boleh.
Okay, and then the next one, the volatile liquid enters above the carbon bed. Carbon bed is example of adsorbent. It will pass through the carbon bed and finally leave at the end of the drum as a cleaner gas. Okay, ni just tunjuk contoh sajalah. Okay, the next part is the fluidized adsorber. Okay, so kalau you tampak gambar ni macam statik kan. Okay, before we read all of this wording, okay, I want to show you the YouTube animation how this fluidized pad macam mana keadaan adsorber tu sendiri. Okay, boleh nampak ke? Boleh nampak tak?
Boleh.
Okay, so I will start to play with this. Oh, sorry. Okay, can you see now? All the adsorbent, okay, is floating. Dia moving. Ini baru betul-betul moving. So yang tadi tu rotary tu dia masih static. Okay, at that condition, tapi yang berputar hanya rotating drum. But this one, all the adsorbent is floating, okay, or moving. So what happened in this condition is that, okay, so the polluted gas will comes from the bottom, okay, polluted gas, and then it will be injected into this fluidized bed. Okay, so finally all this fluidized bed, okay, the adsorbent contents here will trap all the particles. Okay, tapi contohnya kalau you compare moving bed efficiency and also fluidized bed efficiency, do you agree if I said that the fluidized bed will have more surface area contacted with the particles compared to the moving bed? Is it true? Do you agree? Class? Do you agree? Again, I repeat, do you agree that the fluidized bed, okay, the adsorbent in the fluidized bed has more surface area which is contacted with the particles compared to the moving bed just now? Do you agree, guys?
Yes.
Sebab? Why? Logically, you can see the answer is in the animation. Why is that? Ada sesiapa nak cuba? Okay. Okay, the analogy is very simple. When the adsorbent is floating, meaning there will be more surface area, okay, on the adsorbent, which is will be exposed to the particle yang daripada gas polluted gas tadi. Kalau macam you tengok moving bed tadi, moving bed maksudnya sekarang yang tadi tu adsorbent tu static. So mungkin ada part of the surface yang boleh stick dengan particle dan ada part yang maybe tersembunyi sebab dia rapat to each other. Okay guys, boleh faham Kalau
Faham, madam.
okay, kalau yang dia macam semua surface area dia kena. Semua surface area dia boleh stick to the particle. Okay, sebab dia floating. Okay. Tapi kalau macam untuk moving bed tadi, maybe part yang you imagine that you have particle 1 and particle 2 which is close to each other. So part yang dia close to each other tu maybe dia tak kena lah particle gas yang masuk. Okay, maybe dia terlindung ataupun tersembunyi dekat situ. Itu dari segi efisiensi lah. So it means that the fluidized bed is much more efficient compared to the moving bed. Okay, so as I was saying just now, the polluted gas will be injected from the bottom, okay, and then through the adsorbent, okay, so the particles will be trapped into this adsorbent, and finally we have the cleaner gas which is will be exhaust at the top. Okay, boleh faham Class, any question on this?
Tak ada, madam.
Okay, lagi.
Okay, so a few more slides before we end our class today. Okay, since you have seen all the animation just now, so I hope that we can understand this explanation better. Okay, it contains a shallow. Why it is shallow? Usually dia punya length dia tak panjang lah. Okay, yang tadi you tengok And then the floating bed of adsorbent, air will flows upward. Okay, as I was saying from the bottom. Okay, yang kenapa shallow biasanya kalau kita letak dia punya adsorbent ni, biasanya the height of the adsorbent inside of the collar will not be so high. Okay, sangat dia akan jadi maybe 1/4 or dia takkan sampai half of the height. Dia akan jadi very maybe dia akan jadi 1/4 of the adsorbent height. Dia takkan sangat tinggi Kenapa dia punya space dia shallow? Because bila dia float, okay, so you will have enough space untuk untuk dia floating. Okay. Okay. And then okay, so the air flows upward, okay, expanding the bed. Okay, and since kita ada expanding the bed masa floating tadi, sebab tu you tak boleh letak adsorbent tu terlalu pack dalam column. Dia mesti dalam at least 1/4. So that bila dia floating, dia expand, dia still ada space untuk dia float. Okay, so suspending and fluidize the adsorbent and provides more efficient contact, okay, between the gases contaminant and also adsorbent. Ini yang saya kata tadi lah. So fluidized bed because we will have a much more surface area contacted between the gas contaminant and also adsorbent. Okay, and then finally we have the purified air, which is that will live at the top of the unit. Okay, and then the adsorption and desorption. Okay, this is the desorption yang saya bagi tahu tadi. Okay, once it is adsorbed, Okay, because we know that the adsorption treatment is very popular because the adsorption is very cheap, okay, and it is highly efficient. But even though it is very cheap and highly efficient, we have the break point. Break point maksudnya at one point the adsorbent akan jadi saturated. Okay, once it is saturated, you have two ways or two method how you want to clean up the adsorbent. Okay, sama ada you generate semula. Regenerate means you clean up the adsorbent and you reuse it again. Okay, ataupun you one use saja and then you terus buang. Okay, basically kita kalau boleh kita tak nak macam one use saja. Okay, so what you do is that usually once the adsorbent becomes saturated, okay, so we tend to wash out, okay, ataupun regenerate, dengan bahasa lainnya regenerate, so that you can reuse, okay, for the second time, third time, fourth time and so on. Okay, so sebab tu kita kena buat regeneration. But actually not all industries can regenerate the adsorbent, because if let's say the pollutant is very very toxic, you cannot regenerate it. Okay, sometimes you kena buat one use saja dan you kena terus buang ataupun tukar yang baru. Okay, kalau non regenerative ni yang tak boleh generate sangat costly lah, because every time you have use it, you kena tukar baru. So kat situ akan jadikan cost tu naik lah. Okay, and then anti-break point, so saturated adsorbent. Okay, kalau you tengok the most popular chart, okay, untuk explain the adsorption behavior, okay, pun tak ada dalam ni. Saya share ni ya. Ni just nak tunjuk sajalah. Okay class, have you seen this chart before? Pernah nampak tak chart ni? Siapa yang buat RP1 dia tahu kot. RP1. Okay, so this is actually known as breakthrough curve. Okay, breakthrough curve, this is actually to explain the behavior of the adsorption. Okay, contoh. Let's say you have the graph here. It is graph the adsorption capacity in milligram per gram versus time. So at time equivalent to 0, imagine dalam fluid aspect tadi okay, you have adsorption capacity has been increased. Okay, at one point pada TB ni adalah breakthrough time. This is where the absorption is almost 100%. Okay, dia punya efficiency dia akan terus increase, and then selepas dia become saturated, dia akan denote as a adsorption time. Okay, adsorption time. So kalau dah sampai TE ni, maksudnya this is the time yang you kena stop the operation and do the regeneration of the adsorbent. Okay, ini contoh sajalah 120 minit, tapi dalam industri maybe dia akan pakai dalam few days ataupun few months baru dia akan regenerate. So ini pun depends pada application. Okay kelas, boleh faham So kalau macam eksperimen tu ataupun industri tu dia dah sampai pada TE, okay, adsorption time, maksudnya you tahu it is time for the replacement ataupun regeneration of the adsorbent. Okay class, are you following?
Yes, madam.
Okay. Okay, so I think we come to the last part. Okay. So two type of adsorbent saya bagi tahu tadi, regenerative and also non-regenerative. Okay, this is just to give you example how you regenerate it. Maybe you use the superheated steam to clean off the adsorbent, ataupun guna circulating hot air, atau you boleh juga cool the bed before you reuse it. Okay, other ways maybe by burning process, pressure reduction or chemical treatment. Okay, and then usually if you want to use to do the regeneration, kita selalunya install minimum 2 units of adsorber okay, dalam regeneration. Application such as dry cleaning, degreasing, solvent extracting and so on. And another example, maybe you ada recovery of valuable material from organic vapor, and then sometimes it is economically feasible. Okay, example lah, contoh you collect the SO2 from the flue gas in order to get sulfuric acid. Okay, so saya tak sempat nak cover yang the last three ni, nanti saya akan buat pre-recorded video boleh Okay, the video on the last section and also together with the pre-recorded video on chapter 5. Okay, on chapter 5, then once you come back from the New Year break, kita akan terus masuk chapter 6 dan juga tutorial chapter 4. Okay class, I think that's all for today. Thank you very much for your attention. Assalamualaikum.
Okay, madam. Thank you, madam.